So hey, hello everyone, and I welcome you all to the IIT JEE Rankplus English. In today's video, in our one-shot series, I am going to cover the current electricity. This is the one of the most important chapter because if you see the number of questions which is coming from this chapter, in 2024, there were around 34 questions in 20 shifts. So you will be finding at least two or one questions from this chapter. So this chapter is very, very important. And we will start without wasting our time. But before we start, the very important point is that you have to join our Telegram group as well, because in this Telegram group you will be getting the daily practice paper. You'll be going to get the PDF file of the video which I am teaching you. The third one is the important notification, so that you won't miss any notification. Next, in today's video, I am going to cover, first of all, I am going to cover the theory part, a quick theory we will be doing. Then I'll be telling you important questions or important patterns which is required to learn the particular concept. And the third thing is the previous year questions from JEE 2024. So it's a power pack session comprising of these three things. First one is the theory, second one is the important questions, important patterns, and the third thing is the previous year questions from JEE 2024. So this is going to be my flow. This is particularly a syllabus for JEE 2025, and I hope that you all are ready. My future engineers, are you all ready to ace this chapter? This chapter is very easy. And why I think that this chapter is very easy, because I'm an electrical engineer and I have learned the basics of these in 4 years, and you can see. So shall we start? Okay, Akhilesh, hi. Please take full optics and modern physics. Optics is a very big topic. I think that I need to take on Sunday, because before this one shot session, I am also having the other paid classes on Rankplus. So I'll do that, Akhilesh. Your name is Akhilesh, right? So let's start. And as you know that what is the X factor which your sir, Manoj Kumar sir, is having. My X factor is that I am able to concise the toughest topic, the toughest pattern in a very simplest way, so that you can remember that thing and you can easily revise those topics, right? So this is my X factor. So here, let's learn the concept of current. Let's learn the concept of current and the important pattern on which the current questions will come in your exam. So as we know that anything which moves, right, current means the movement. And if there is a movement of wind, we will say wind current. If there is a movement of water, we will say water current. But here, the particular chapter, in this particular chapter, we are going to learn the electric current. And in the electric current, basically we will deal with the flow of charges. So if somebody asks you that what is electric current, so you can tell them that electric current is basically the flow of charges. The flow of charges, simply. And how you can calculate the current, right? Now, this is particularly what is current, what is electric current. Now, how you can calculate current. So now we will talk about calculation of electric current. So the first part is average current. So for average current, it will be Q by T. Q you can write it as any. We know that according to from quantization of charge, we know that Q equals to any, right? I hope that you know that. So this is first one is our average current, and the second one is instantaneous current. The second pattern which we must know is instantaneous current. Instantaneous current. So for the instantaneous current, you can write this I equals to differentiation of the charge dq by dt. Okay, and based on this, I think that you will be getting multiple times. Take an example. Take an example. If I am having a charge as 5t square plus 2t plus 50. Okay. Now, if you have to find current, you have to find out current at t is equals to 2 seconds. You have to find out current at t is equals to 2 seconds. So what you going to do in this type of question, you have to first differentiate it to get the equation of current. You have to first differentiate this equation what is given here. So when you differentiate it, you will be getting, you have to remove the power and decrease the power. So if this power comes in front, it will be 10t plus 2. Okay, this is what I'll be getting once I'll differentiate this. And you have to put t equals to 2 seconds, and if you put the value, you will be getting 20 plus 2, 22 ampere. It's a very huge current which we are getting. I hope that this thing is clear, right? Now, similarly, if I know this formula, you can also say that, sir, if I have to calculate dq, then dq will be I dt, right? dq will be I dt. And if somebody asks you that you have to find out the charge, if somebody asks you that you have to find out the charge, so charge will be equals to integration of dq, and it will be I dt. Okay, this is also a very important formula. This is also a very important formula. And using this, sometimes we have a graph between current and time. Sometimes we are provided by a graph between I and t, and there will be a curve, and you have to find out the area. So this area under curve, is I dt, which is equals to charge. Okay, this area under curve is I dt, which is equals to charge. I hope that this thing is clear. You can easily find out, right? Shall I give the question? Let's have this as our question. What if we have been provided by, what if we have been provided by that I is equals to 10t plus 2, and you have to find the charge flowed in, charge passes in 2 seconds. Then you have to do the integration, right? You have to do the integration. There was some student who was asking me, sir, I'm still confused at when to do integration and when to do differentiation. See, doing the integration and differentiation basically depends upon what you need to find out. It particularly depends upon the knowledge which you are having about the relationship between the two values. So sometimes you have to differentiate. Like here, if I need to get the current, so current is basically the rate of change of the flow which we are getting here, dq by dt, the rate of flow of charge, right? So for that I have to integrate. For that I have to differentiate. Sorry, for getting the current, basically I need to differentiate the function which is given for the charge, and to get the charge from the current I have to integrate the function of I, right? I hope that thing is clear. So here I need to integrate this. So you'll be getting 10t plus 2. You have to integrate it. and you'll get 10t square divided by 2 plus 2t. That will become 5. And now you can put the value to second here, 0 to 2 second. Four, 5, 5, 20, 24. So 24 column you will get. Okay. I hope that this thing is clear. Is it clear, my dear? Right. So these types of questions you will get in your exam: average current, instantaneous current. And another type of question is third type. You will be provided by a cross sectional area. There will be a cross sectional area, and from this cross sectional area there is charge q1 plus q1 is moving plus q2 is moving. And if somebody is asking you that what is the current, so for a particular time t, for a particular time period t, we have to calculate the current. So current will be equals to q1 by t plus q2 by t. Okay, so this is how we are going to find out. And sometimes it might also be possible that you will be getting let's write in this format. This is case 1. This is case 2. Sometimes it might this condition might also be possible. So you can write q1 by t minus of q2 by t. Okay. So this is the third type of question which we might get in our exam. The fourth part is circular current. The fourth pattern is circular current. You will be provided a situation in which an electron is revolving. You will be provided by a situation in which an electron is revolving. Let us consider it is going with the velocity v, and the charge on this is q. Okay. And if somebody is asking that this we are having basically we are having a charge which is moving round, which is taking a round in a circular manner around any fixed charge you will be having. Okay, so for that particular case you have to find out that what is the value of current. So my current will be equals to q by t, right? That is the formula which we are having. But you know that speed is equals to 2 pi r divided by time. So your time will be 2 pi r divided by v. You can substitute this thing. I'll change this color to this. You can substitute this thing. So you will be getting q 2 pi r and v. So that is the value of current which we will get. Okay, similarly, you know that since v is equals to r omega, so if you substitute the linear speed, if you substitute the linear speed with the angular speed, so you will be getting I is equals to q omega divided by 2 pi. So these are some very important patterns of the questions which you might get in your exam. I hope that these all patterns are clear to you. So This is basically a concise, quick revision for the concept of electric current. Our first topic is clear. We have to study the electric current, right? Our first topic is clear. In this topic, we must know about these points only. That current can be asked out of these four patterns. The first one is the average current, they can ask you. Second one is the instantaneous current, they can ask you. And in the instantaneous current, I have seen that recently in JEE 2024, JEE 2023, you got some questions regarding this, that either equation is provided, you have to calculate the current, or it might also be possible that something like the equation of current is provided to you and you have to calculate the charge. I hope that this thing is clear to you. Tell me. Is it clear, my dear? Ars zero. How the work done will be zero? I hope that this thing is clear. Please do let me know. Okay. Array, is it clear? Shall we? Shall we move? Shall we move? Let's do some questions which might be there from. Yes, that is the question. So in JEE 2024, first Feb shift 1, there was a question in which you have been provided by the equation of current. The equation of current given to us is 3t square plus 4t cube. That is the equation of current. And you have to find out that how much charge is flown through a cross-sectional area from 1 second to 2 seconds. What must be your approach? First of all, you must know that what is the formula of current. So current formula is equals to rate of flow of charge dq by dt, and they are asking us the charge here. So if they are asking us the charge, we need to integrate this thing. I hope you are getting this thing, right? You have to integrate this, and to integrate this, dq will be getting 3t square plus 4t cube dot dt, right? So your key 3t cube divided by 3 plus 4t4 divided by 4, that will be cut here. So you'll be getting t cube plus t4, and this you need to substitute. So the value of q is 8 minus 1, 16 minus 1, 7 plus 15, and the answer will be 22 coulomb. Are you getting the same answer? Are you getting the same answer? Please do let me know. Are you getting the same answer? Tell me. Are you getting this? Arshu, Akhilesh. Okay. Now, there was another question. Let's see that, find that. Yes, this question you can do. Now let's solve this question. In this question, you have been provided that the electric current through a wire varies with time as I is equals to I naught plus beta t. Okay, I naught plus beta t, where I naught is equals to 20 ampere, beta is equals to 3 ampere. The amount of electric charge crossed through a section of the wire is in 20 seconds is how much? Can you find out? I is equals to I naught is 20 plus beta is 3 t. So this is the equation we are having. To get the charge, we need to integrate it. I'll be getting 20t plus 3t square divided by 2, right? They're asking in 20 seconds, you have to substitute this. So your Q will be 20 into 20 plus 3 by 2, 20 into 20. 400, 600. So 1000 coulomb. 1000 coulomb is our answer. Is it clear, my dear? Right. Are you getting that which type of questions are coming? Because these questions are very, very important. Right? These questions are very, very important. Now let's move towards the another question. I think these are the only questions. If any question comes again, you can do on your own, right? Let's move to our theory part again. Okay. So the first topic was electric current, and in those electric current topic, basically I need to know the four concepts. The first concept was about the average current, the second was about the instantaneous current, the third was that if you have been provided by the amount of charges that are passing through a particular cross section, you have to think in terms of picture and pixel concept, which we have already discussed, right? You do not need to see the picture, you have to see the pixel. What is pixel method? The pixel method is that you need to divide the particular very big question into a smaller chunk, and if you have a smaller chunk of question, you can easily solve that, right? Now the last part, the fourth section, is of a circular current if we are having. Okay, so that is what you need to know. I hope that this thing is clear. Now let's move towards the another thing. Let's move towards the another thing, that is the relationship between the current. Important relationship we must know. Important relationship you must be knowing. First of all, let's draw ये मैंने यहाँ पे ले लिया. I have taken this thing. Okay, important relationship we have to find out. Now let's suppose the length of this wire is L and we have provided a potential here. So that side is having a positive potential and this side is having a negative potential. And due to this, when we are connecting a potential, there will be an electric field, right? If we have like provided a potential here or a battery, there will be an electric field, and due to that electric field, the electrons out there will experience a force, and that force will be equals to minus ee, and due to this force it also get accelerated, and we know that acceleration can be easily find out using the Newton's second law of motion, that force is equals to mass into acceleration, right? And from here you can get that acceleration from 1 and 2. From 1 and 2 we get acceleration is equals to minus ee by m. And if acceleration is equals to minus ee by m, and initially I am considering that initially the charges are at rest, so to get the final value I can use u plus at, and initial velocity is 0, you can mark it as at, a is minus of ee by m, and the average relaxation time we are considering here, tau is where tau is average relaxation time, that is the time duration between two successive collision. This is tau is average relaxation time, and this Vd is known as drift velocity. This Vd is known as drift velocity. Vd is equals to minus of ee by m tau. I hope that this thing is clear. Okay. Now, if this drift velocity is clear, the mobility is very easy. There is also another term, mobility, which is the magnitude of the drift velocity divided by the electric field which we are providing. So that going to be minus, no, minus will not be there. It will be E by m tau, E tau by m. Now this mobility basically depends upon the relaxation time, and if you increase the temperature, the relaxation time will decrease, right? Because the particle will be moving very fast. I hope that this point is clear. Now, the third thing is the relationship between the drift velocity and the current, because due to this motion, the current is flowing through the wire. So we must be knowing important relationship between the drift velocity and the current. So I is equals to Vna, Vd E N A. I is equals to Vna. This is very, very important relationship between the drift velocity and the current. Manish, Sigma guy, 10th B Master Tamil. Are you a friend of Akhilesh, Manish? Where are you from, Manish? Where are you from? I hope that this thing is clear. Right? Shall we move now? Shall we move forward? Okay. Now, if this thing is clear, the next pattern is that we must be knowing that how to calculate the equivalent resistance. Now, we must be knowing that how to calculate the equivalent resistance, because you will see that there are multiple times, you will be getting direct question to find out the equivalent resistance. This is the simplest question which you can expect in your JEE exam. The first thing is when there is series connection. For a series connection, I can say that if there is a resistance R1 and R2, they are connected in series, the R equivalent will be a simple addition R1 plus R2. And what if they are connected in parallel? So for parallel connection is when they are connected across each other. This is R1, this is R2. For this, you have to do some calculations. This 1 by R equivalent is equals to 1 by R1, 1 by R1 plus 1 by R2. Or you can write it R equivalent is equals to R1 R2 divided by R1 plus R2. Okay. Now there could be a very special case. Let me discuss the special case also. Special case, if all the resistance are same and you are having n resistor, R. So R equivalent will be NR. Okay, and here this is R, 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 R. And now I'm saying that if all of them are, there are n resistor, there are n resistors connected in parallel, and you have to find out the R equivalent. Basically, this arrangement is known as ladder circuit. The R equivalent will be equals to R by N. This R equivalent is equals to R by N. For the complex structure, you have to think in terms of the steps which I am telling you. Okay, these are the basic thing which you must require, because without them you won't be able to solve the question of equivalent resistance. So these are the basic steps, and once you know these basic steps, because these are from class 10th, right, the next thing which you must know is Wheatstone bridge. You must know about the concept of Wheatstone bridge, right? What is Wheatstone bridge? If R1, R2, R3, R4, this is R5. Wheatstone bridge says that if R1 by R2 is equals to R3 by R4, then ignore R5. So your circuit will become like this. And I hope that this is the easiest circuit which you can easily solve, because these two are in series. These two are in series, right? These two are in series and these two are in parallel. Okay. So for Wheatstone bridge, you have to do this thing. And once this Wheatstone bridge is done, then you have to apply point potential method. I'll teach you that what is this point potential method. This is a very useful method. Then if it's going out of our range, we'll be using KCL and KVL. And if we won't be able to solve using the KCL and KVL, and if you feel that the question is getting more complicated, then we will be using star delta transformation. If star delta transformation you won't be able to do, then we will go to some higher approach. Okay, so there are folding methods. There are folding methods, and there is we will look for the symmetry. So there are something which we can do. Using those methods, we can solve them very fast. Okay, let's solve. I'll see that whether you'll be able to get the answer correct or not. Very simple question I'll be giving you. Okay, this is the question. Tell me, you have to find out the equivalent resistance of the following network. This is the network being provided to you. You have to calculate the equivalent resistance. Calculate the equivalent resistance. Tell me. Hello, Tulsi Kumar and Naveen Narasimha from Tamil Nadu. Great. Good to know you. Calculate the equivalent resistance. You have 40 seconds left. Where are you from, Tulsi Kumar? Eight. So 8 you are getting. Are you all getting the 8? Are you all getting the 8? See here, as this circuit is short, so you'll be having 2 and 2. It will become 1. 1 and 2 become 3. 3 and 3 becomes 1.5. 3 by 2. And then 3 by 2. 3. Ohm and 3 by 2 ohm you are getting. Okay. Now we know that our answers will be less than this 3 by 2. The R equivalent will be RAB is 3 by 2 into 3, 3 by 2 plus 3. One ohm. 1 ohm is your answer. Are you getting the 1 ohm? If you want to do like this, 1 by R equivalent is equals to 2 by 3 plus 1 by 3. You'll be getting 3 by 3, 1. So R equivalent is equals to 1 ohm. But I have used a very simple approach that RAB is equals to R1 R2 divided by R1 plus R2. So this is what I'm doing. See here, as this wire is short here, so this we won't be considering this 6 ohm. Why? Because this wire is short. So we are only left with this 2 ohm, and these 2 ohm and this 2 ohm is in parallel. So we will get 1 ohm here, and this 1 ohm is in series with this 2 ohm. So I'll be getting 3 ohm. And this 3 ohm and 3 ohm are in parallel. So I'll be getting 3 by 2 ohm. So, and this 3 by 2 ohm is parallel with this 3 ohm. So I'll be, if I'll solve this, I'll be getting 1 ohm. So my 1 ohm will be my answer. Tell me, calculation mistake. So it was not, right? It was not the value which you are getting. Right? Shall we move? Shall we move? Yes. I hope that this thing is clear. Now, there was like another question. Let me consider another question for you. Before we discuss the Kirchhoff's law. Not this, not this, not this. Yes. Solve this circuit. In the given figure, this is a question which we have. In this, we have been provided that R1 is equals to 100 ohm, R2 is equals to 8 ohm, R3 is equals to 4 ohm, R4 is equals to 8 ohm. Battery is idle with EMF 12 volt. So there will not be any internal resistance in this battery. Equivalent resistance of the circuit and the current supplied by battery respectively. So first of all, you have to calculate the equivalent resistance here. Tell me what will be the equivalent resistance of this circuit. Because if you see here, for two of the options, the values will be same. So at least my two options will not be there, right? It's like 50-50. So this 4 and 8 are in parallel. So if these are in parallel, I can solve it using 4 into 8 divided by 12. So I'll be getting 8 by 3. And this 8 by 3 is in parallel with first of all, let's do it in a very easy way. This 8 and 8, because all of them are in parallel, right? So this 8 and 8 will become 4, and this 4 and this 4, this is 10 ohm. This 4 and 4 will become 2. So my like this won't be my answer and this won't be my answer. So I am getting R equivalent as 12 ohm. Are you getting R as 12 ohm? Please tell me. Because all of them are in parallel. right? I'm telling you that R3, R4 and R3, R2 and R4, all of them are in parallel. You can draw this circuit. You can draw this circuit like this. This is a 12 volt. R1, consider this as 10 ohm. Here I'm having 3 resistance. This R2, R3 and R4. So this R2, R4 and R3 are in parallel, and easily like how I solved it, I know that there is a ladder circuit. If both the resistance are same, here we are having 8 ohm and here we are having 8 ohm. So both of them are having the same resistance and they are connected in parallel. So just I need to do is I need to calculate the how many resistors are there, and I need to divide that value with the number of resistors I'm having. So here 8 and 8, there are 2 resistors. So 8 divided by 2, I'll be getting 4 ohm. So replacing these two, I'll be getting 4 ohm. And now again 4 and 4 ohm is coming. So 4 divided by 2, I'll be getting 2 ohm. So once I'll solve this thing, I'll be getting 2 ohm. So here I'm having 2 ohm and this 10 ohm. So I'll be getting 12 ohm as R equivalent. So R equivalent will be 12 ohm. We are having this as 12 voltage, and I hope that you must be remembering that there is a concept of Ohm's law, and Ohm's law states that V is equals to IR. And if somebody asks me that what is the value of current, so current will be equals to V by R, you can say that it will be equals to 12 divided by 12, it will be 1 ampere. So my answer is second. Sir, I belong to ST category and I am aiming for tier 2, 3 NIT. Any branch prefer CSC? So ideally, how much I should be targeting? First of all, I need to potentiometer and meter bridge is basically potentiometer is not in the syllabus, but last year I have seen one question was there. See, I'll show you. Potentiometer is not in the syllabus. This is particularly JEE Main 2025 syllabus. So in this, you won't find potentiometer. Wheatstone bridge is there, meter bridge is there, but you won't find potentiometer. But if you see the previous year, syllabus is same. JEE 2024 syllabus and JEE 2025 syllabus, you won't find any change. Even the formatting is same. Even the like the font which they have used is same. Just copy and paste. But if you see the previous year question, like this one, JEE 2024 4th April shift 1, here you will find that potentiometer. But even if I do not know the concept of potentiometer, I am able to solve it, right? So little bit I think that you must be knowing about a potentiometer. I'll teach you that thing here in this class. I hope that the previous question was clear to you. Was it clear? Now let's move. This question is clear. Okay. Ratio of heat they are asking. Okay. Now again the equivalent resistance question. JEE 2024 5th April shift 2. JEE 2024 5th April shift 2. There was a question on equivalent resistance. Why I am emphasizing on finding the equivalent resistance, and why I want you to like at least you must solve the HC Verma back exercise question from this current electricity chapter, because this is one of the most high weightage chapter in your JEE exam. Okay. So solve this question. I'm giving you a timer here. Just 1 minute you are having. It's a real exam paper question. JEE 2024 5th April shift 2. So the question is saying that a wire of resistance 200 ohm and it's divided into 10 equal parts. 200 ohms. So how much will be the resistance of one part? 200 divided by 10, 20 ohm, right? Resulting pairs A combination of two parts are connected in parallel and so on. Now, resulting pairs of parallel combination are connected in series. The equivalent resistance of final combination is what? You have 24 seconds left. Being Chima, let's solve the question and then we will talk about it. Naveen Narasimra. So where are you from? Being Chima? Being Chims, where are you from? And I'll suggest you to, like, there is a website of JOSA. Go to JOSA website and there you will find the cutoff. It's a counseling website. There are few steps which you must know. First of all, for the exam, you have NTA. NTA will conduct the exam and will give you the rank. Right? NTA work is done. For getting the admission in NIT, IIT, you have a special counseling session will be going on, and that counseling happens on JOSA website. In that JOSA website, you will find last year cutoff. I will tell you 2022 cutoff, 2023, 2024. Okay. So basically, these cutoffs will give you an idea that at what score you will be getting which NIT or IIT, right? But currently, we are not into that situation. Here, first we have to clear the cutoff which is required. At least you must be targeting 200 plus marks in your JEE Main January session. January session is very easy and very important because I have seen, and I'm a staunch believer of data. I believe that in 21st century, your decision must be based on data, not on emotions. Because if you go in emotions, there will be a lose motion. So I'm telling you that in January, it's very easy to score higher percentile from a very low score. But in April, even if you increase 15 or 20 marks, your percentile will not increase. Right? So it's difficult to get a good percentile in April as compared to the January session. Because there you will find multiple students who are coming, who are only preparing for their board exam in January. They will be also there. Right? Now tell me, are you able to solve it? Did you get the answer correct? Or do you want more time? Let me give you 1 minute more. So do thermodynamics chapter. Thermodynamics, Jevant, are you in class 11th or are you targeting JEE 2026 or 2025? Thermodynamics, I'll do not separately. I'll do a thermal physics session. In that thermal physics session, I'll cover the thermal properties of matter, thermodynamics, and the KTG. So I'll be covering all the three concepts. JEE 2026. That's why I think that's why you are saying that, sir, please take thermodynamics. I'll take that thermodynamics later on. Basically, in my lectures, you will find a complete theory, the important questions, and the third one is the JEE 2024 real exams paper. Solve it and do let me know. 3 seconds. Array, you're not doing it. Why? Where are you facing issue? Please do let me know. Where are you facing the issue? See, the easiest way to get success is first do what is necessary. First do what is necessary. Next do What is possible? So first of all, when you are preparing for any competitive exam, you must be focusing on completing the full syllabus, because once you know the complete syllabus, that is the necessary thing. Then do what is possible, the previous year question, the extra materials, the study materials, right? And soon, before you know it, you will be doing impossible things. Soon you will be achieving the impossible result. The result which was first, you think that it's impossible, but suddenly you you will feel that yes, it's quite possible. So you won't be able to solve that question. Anybody? Arey, do let me know, yaar. Why you are not able to solve it? Huh? Tell me. Any answer? Because this question was from JEE 2024 April attempt, and in this question you do not have any options. So if you do not have any option, you have to solve it, and then only we can check that what is the answer. Shall we go? Okay. So wire of 200 ohm is divided into 10 equal parts. So resistance of each part will be 200 divided by 10. A wire of resistance is 200 ohm divided into 10 equal parts, resulting pairs. A combination of two parts are connected in parallel, and so on. Okay. So 20 ohm, 20 ohm. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you will be getting 20 ohm, 20 ohm, 20 ohm. Now the resulting pair, combination of two pairs are connected in parallel. The combination of two parts are connected in parallel, and the resulting, okay, it's not like that. It's not like this. It's that if we are having a wire of R resistance, the combination of two parts are connected in parallel. So basically we are connecting them in parallel like this, 20 ohm, 20 ohm, and then we are taking this in series. Okay, how many pairs will be like this? 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? 20 ohm, 20 ohm. There will be 5 pairs. 5 pairs like this, because in total we have 10 resistance, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. Now the equivalent resistance of this part is 10 ohm plus 10 ohm, or you could say that the R equivalent will be 10 into 5. So I'll be having 50 ohm. Equivalent resistance of the final combination is 50 ohm. Is it clear, my dear? Is it clear, my dear? How we are going to solve this question? Okay, done. Done. Shall we move? Now, next question. Next question is the value of unknown resistance you need to find out, for which the potential difference between B and D will be 0. So here I'm having 2 points B and D. Here I'm having 2 points B and D, and I need to get the potential at these 2 points to be 0. So how the potential will be 0? The potential can only be 0 if this is a balanced Wheatstone bridge, right? If the potential at B equals to potential at D, that means the bridge is balanced. So to balance the bridge, I can do this is 14.5. This value is 14.5 volt. This is 0.5 ohm. This is 12 ohm. 12 ohm. It's X, 12, 12, 24, and this 1, 1 and 1. Okay. So now let's redraw this diagram. This 12, 12 become 24, 24 and 24 will be 12 ohm. So I'm having a point here. It's 12 ohm. It's 6 ohm X. And here I'm having 0.5 ohm. Here I'm having 0.5 ohm. Okay, now I know that these bridges must be balanced, and to balance this bridge, it's very now it's, I think that the question is very easy, because I believe that you must be knowing The balance condition, Wheatstone bridge balance condition is that these Wheatstone is balanced. Balanced condition is when R1 divided by R2 is equals to R3 divided by R4. So this is the bridge balance condition. So you are seeing here that 0.5 and 0.5 is same, right? So this is balance. So if there is 12, there must be a 12. If there is 12, there must be a 12. Then only I can say that these are balanced, right? So here I am having a 6 ohm. So what must be the value of X? So X must be 6 ohm. X must be a 6 ohm. Are you getting my point? Are you getting my point? Is this thing clear, my dear? Fast. Please let me know. I think this point is clear. Jayavant, Bing Chima, Naveen Narsim, Akhilesh. Is these points clear? Alright. Tell me, is this thing clear? Now, shall we move? The next question. The next question is wire of resistance R and the radius is R stretched till its radius becomes R by 2. If new resistance of the stretched wire is XR, then the value of X is, what will be the value of X? So this question is from JEE 2024, 6th April shift 1. According to this question, you have the resistance of the wire is R, radius is R, small r. Okay, and you have stretched till its radius becomes R by 2. If new resistance of the stretched wire is resistance is R, here R dash is XR, and you need to find out the value of X. See, this is the simplest question which you can have. Why I am saying that? Because see, it's a pattern. When you are stretching, when you stretch, compress, or remold, condition is volume remains same. Condition is that volume remains same here. And if volume remains same, you can do one thing, that L1 A1 is equals to L2 A2. This you can use. So here also, if I'm considering the length is L, the R, I can write this as R is equals to rho L divided by pi R square. So this is my R. Here for R dash, I'm having rho. L, I do not know that by how much this L has been changed. So I could write this as L dash. But I know that the area being changed by the area is being changed by 1 by 4, right? So this A dash is A by 4. So if A dash is A by 4, I can say that L dash is equals to 4L. So L dash is 4L. you can write it's 16 rho L divided by pi r square. So it's 16 times of r. I hope that you are able to understand. So now the value of x, we have already find out the value of x here is 16. But the pattern which I am telling you is, if there is a wire of length L, area A. If I am having a wire of length L, area A, then resistance R. If you are stretching this to a NL length, if you are stretching this to a NL length, the area will become A by N, and the R dash will become N square R. Okay. So if initially the length was L, you are not changing the material. If you are increasing or decreasing, it doesn't matter. If the length becomes NL, the resistance becomes N square times of R. Right? Tell me, is this thing clear? Now let's move. If this point is clear, we can go for the next question. Next question is also from JEE Main 2024. 6 April shift 2. What does this question say? Question says that a number of electrons flowing per second in the filament of a 110 watt bulb operating at 220 volt is. So they are asking you number of electrons. So that means N you have to find out, and the value of electric charge is also given to you. We must be knowing that this 110 volt is basically the power, and it is operating at 220 volt. You know a formula that power is equals to VI. So if I'll substitute 110 here, the operating voltage is 220. I can easily find out my I. So my I is equals to 11 divided by 2022. This is 22. I'll be getting 1 by 2, that is the 0.5 ampere. So my current value is 0.5 ampere. Right? So this is what I'm getting here. Now you know that I is equals to Q by T, and if I is equals to Q by T, you can easily substitute this by NE by T, right? Okay. Now you have to find out the value of the number of electrons flowing through it. So that N will be equals to IT divided by E. And to get that, you have I value is 1 by 2, that is 0.5. I'll write it 0.5. Time is 1 second, and electron value is 1.6 into 10 to the power of minus 19 coulomb is provided to you. And time we have to consider, as we have to find out per second, you can consider time as 1 second. So if you are well prepared for the JEE exam, you must be knowing that in electrostatic, we basically calculate that how many number of electrons are there. We generally calculate that how many numbers of electrons are there in 1 coulomb. And in this question, I can do 0.5 into 6.25 into 10 to the power of 18. So my answer will be this one. Okay, I do not need to do the calculation. Then if I have done this much, I can easily get my answer verified from the options given, isn't it? I hope that this approach is clear to you. Is it clear, my dear? Jayant, is it clear? Right? Now let's move to the another question. This question is from JEE 2024, 6th of April, and the shift was shift 2. In this question, a very simple circuit diagram is given to you. In the given figure, an ammeter consists of, there we are having an ammeter. This image is quite, I think, distorted image we are having, right? So I'll draw a separate diagram here to get a clear view of this image. It's 24 volt. It's 140.4 ohm. 140.4 ohm. Okay, now I need to know that what is the value of current here. So just simply I need to get the I here. In the given figure, an ammeter consists of 240 ohms a coil. Okay, now this is not an ideal ammeter we are using. Here we are having a 240 ohm resistance being provided, connected in parallel to a 100 ohm shunt. Okay, there is also a 100 ohm shunt. And now you have to calculate that what will be the reading of the ammeter. How you're going to solve it? I'm giving you 1 minute. Solve it. JEE 2024 real exam question from shift to 6th April. And do let me know if you're facing any issue. The being chima. The being chims me also same. I'm Charan. Charan, where are you from? Telugu. Miru ellannaru. It's done. So first of all, you need to find out an equivalent resistance. So this R become 100 into 240 divided by 340. I can get the value here. Okay. With this 100 into 240 divided by 340, you'll be having 70.58. 70.58, and the R equivalent is 140.4 plus 70.58. So this is the value of resistance which we will get. And once we are done with this R equivalent, you have to find out I. I is equals to V by R. So V is 24. V is 24. 24 by R equivalent, 210.58. I think there is so much calculation in this question. I think either the data, there is some error while typing the question, or the question is very lengthy, right? There is so much calculation which we have to do. We're getting 0.113 ampere. Okay, then you can go for the current divider rule. Do you know that what is current divider rule? Let me tell you the current divider rule. See, it's a golden rule. It's a golden rule. The golden rule are current divider, because many a time you have to use this rule. If there is a current flowing through the wire and the resistance here is R1, resistance here is R2, the current will divided. This is the I current. The current will divide in a ratio I1, I2, right? So as I know that the voltage at this end and voltage at this end will be equal, so the product of I1 R1 is equals to I2 R2. You can get I1 divided by I2 is equals to R2 by R1. So current is basically divided in the reciprocal ratio. Let's take an example here. Let's take an example. Here I am having 6 ohm, 3 ohm, and a current of 3 ampere is flowing through it. Okay, current of 3 ohm is flowing through it. Now you know that if I need to find out I here, I1, I2. So if this is my R1, my I1 will basically depends upon this thing. My I1 will depend upon this thing and I2 is depending upon this thing. Are you getting my point? You have to calculate the ratio, right? You have to calculate the ratio. So my I1 divided by I2, I1 divided by I2 will be equals to R2 by R1, right? So it will be 3 by 6. So it is 1 by 2. And at any time, if you are getting a ratio, you can consider this as that I1 is equals to 1x. Let I1 is equals to x and I2 equals to 2x. And also you know that this I is equals to I1 plus I2. So this is 3. And here you are getting 2x plus 2x. So this is 3x. So x is equals to 1. So if this x is equals to 1, I1 will be equals to 1 ampere and I2 is equals to 2 ampere. Right? So easy to get the answer if you know this formula. Other than that, if I need to get the value of I1, I can use componendo and dividendo, and using that componendo and dividendo, I can write this as R I1. If I need to find out, it will be R2, R1 plus R2, and it's multiplied by I. Similarly, if you need to find out I2, you can have R1 plus R2 I. Okay, so this is a very, very important rule, golden rule, I would be saying. Is this thing clear, my dear? Please do let me know if this thing is clear. Charan, is this thing clear? I hope it is fine. Shall we move? All clear. Yes. There is also a rule which is known as voltage divider. So for a voltage divider, if we are applying a voltage V, there are two resistance. R1 and R2, there is the voltage V. Here voltage V1 and V2. So my V1 by V2 will be having a direct relationship. V1 divided by V2 is equals to R1 divided by R2. Okay. For this, you have another example. Let's take an example. $12 volt. Okay. 4 ohm, 2 ohm. See, and you need to find out the value of V1 and V2. You need to find out the value of V1 and V2. How you can find out the value of V1 and V2? For finding the value of V1 and V2, first of all, you need to find out the total resistance. So the total resistance here is 6 ohm. And if somebody is asking you, you can do one thing. Get the value of current. I'm not disturbing the given diagram. The value of current you can find out. Value of current will be 12 divided by 6, right? So it is 2 ampere. So if this is 2 ampere, 2 ampere of current is moving. So here I am getting a voltage of 8 volt and here I am getting a voltage of 4 volt. So combinedly I am getting a ratio of 2:1, right? Also, I need to find out the potential, point potential, because that concept is also very, very important. Let's understand a very important point, which is known as point potential method. Point potential method. So if I'll taking this example, say I'm having a 12 volt here. If I'm having a 12 volt, what does it mean? What does it mean? If I'm having a voltage of 12 volt, I'm writing it at 12 volt. It means that this end is at 12 volt and this end is at 0 volt. Or it could also be possible that this end is at plus 6 volt and this end is at minus 6 volt. There could be another case that this end is at plus 9 volt and this end is at minus 3 volt. Ultimately, what is the criteria here? Criteria here is the difference between this end and this end must be a 12 volt. Right? So for a simplicity purpose, I am taking that if this is 12 volt, I can consider that at this point I am having a 12 volt. But I know that 8 volt is drop. So at this point, I am getting only 4 volt. Are you getting my point? And at this point, again, I am getting a 0 volt. So from this point to this point, I am having a 4 volt drop. From this point to this point, I am having a 8 volt drop. So I got to know the point potential at this point, and this point. If these points are clear, my dear, we can extend this diagram further. If this point is clear, I can extend this concept further. Assume that I am taking the same example. Let's not change our example. I am taking the same example. And I am now telling you that what if you are connecting the two resistance and that too in the same ratio 2:1. So let me take 30 ohm, and as I am taking in the same ratio that must be a 15 ohm, right? Now, if this is having a voltage drop of 8 volt, this will also be having a voltage of 8 volt. And at this point also, you'll be getting a 4 volt. Because these points are same, right? These points are same and they are at 12 volt supply. This will be at 4 volt, this will be at 4 volt. And if you join them and you put any circuit element out there, either it will be a capacitor or means resistance, it won't be affected, right? There will be no current at all flowing from this point to this point because the potentials are same. That is the condition of Wheatstone bridge. So why we are saying the Wheatstone bridge balance condition? In that balance condition, the potentials that we are getting is same, and this divided by this is equal to this divided by this, or you could say that the ratio of these will be equal to the ratio of these. Is it clear, my dear Charan? Let's move to the question part. Now this question is from JEE 2024 8 April shift 1. The question is asking us that you have to find out the terminal potential difference of the cell, because we know that if this is the EMF of the cell, 3 volt is basically the EMF of the cell, and if we need to find out the potential difference, if we need to find out the potential difference is basically the EMF minus of IR. EMF minus of IR. So they are asking us this thing. So to get that, you must be knowing that how much current is flowing through it. This is the R, internal resistance. So for this, you must be knowing that how much current is flowing. And to calculate the current, we have this 4, 4 and 1 ohm. Do it. I'm giving you just 30 seconds for this because this question is very, very easy. I'm just giving you 30 seconds to solve this question, because this question is very basic. Like just you need to get the R equivalent, and from that R equivalent you have to find out the current value, and using this formula you can get the potential. Now let me know how much you are getting. Charan, Jayavant, Chima, please do let me know. Only 30 seconds, only 2 seconds. Okay, if you haven't solved it, now we know that these two are in parallel and these two are also forming a ladder circuit. What is ladder circuit? One after the another, the resistance are coming and they are having the same value. So if they are having the same value, 4 and 4, I can do it by 4 divided by 2. 4 divided by 2, the 2 will be the answer. And this 2 and this 1 is in series. So my total R equivalent, is 3 ohm, right? The voltage is 3 volt. So my current will be V by R, and I'll be getting 1 ampere. So to get the potential, you have 3 minus 1. So 2 volt. Are you getting 2 volt? Are you getting 2 volt? Tell me. Okay. Shall we move? I hope that this thing is clear. Now let's move. Yes, I think we can solve this question as well. So water boils in an electric kettle in 20 minutes after being switched on. 20 minutes you have to wait to get a hot water. Using the same main supply, the length of the heating element should be this to this times of initial length if the water to be boiled in 15 minutes. Okay, if you want water to be boiled early, how much length you have to increase or decrease, you have to tell me. Now you tell me that, see, there are two options which says decrease, there are two options which says increase. You tell me what you have to do, increase or decrease. Increase, Charan. Charan is saying increase. Increase by how much? Somebody is saying C option and you are saying increase. C option is decreased. Narendran. So how you attempted this question means what was your approach? What was your approach in this question? Basically, if I want a quick, if I want quick supply, then what does it mean? Do I need to increase the power or decrease the power? Let's think in terms of see, I'm having two kettles. Let me have a kettle image here. Let me have a kettle image here. Okay, let's have two kettles. Let's have two kettles. So there are two kettles. This takes 20 minutes and I want it to take 15 minutes. Then tell me which is more powerful. Which is more powerful? Because if I want very fast, if I want my work to be done very fast, I need a powerful machine, right? So if this is having a power P1, this will be having a power P2. I know that this power P2 is more than this power P1, right? And power is equals to V square by R if they are operating at the same voltage, right? It's written here that they are operating at the same voltage. And we know that R is equals to rho L by A. Area of cross section, I am taking that the wire is having the same area of cross section. So using both these things, I can say that power is inversely proportional to length, right? Power is basically inversely proportional to length, and P1 divided by P2 is equals to L2 by L1, right? So you require an L2 which is P1 by P2 L1. So 20 by 15 . Are you getting this? And now power, what is the relationship between power and energy? Energy is equals to power into time. So power is basically equals to energy divided by time, right? Are you getting my point? This is what you need to find out. L2, right? So how much power you will get? Power is inversely proportional to because power is not given to me. So I'll do one thing. I'll choose this thing. L2 I need to find out. L2 is equals to T1. It's T2 divided by T1. L2 you need to find out. It's T2 divided by T1 into L1. So T2 is this. T1 is this. So it's 15 divided by 20 L1. 3 by 4 of L1. Okay. So tell me, your L2 is your L2 is 3 by 4 times of L1. Your L2 is 3 by 4 times of L1. Now you tell me that whether you will increase it or decrease it. The answer is here. Now you tell me that whether we have to increase it or decrease it. Alright, it's there in the question. Increase in length. Huh? Decrease. Because if resistance decreases, my power increases, right? We have to increase the power. So my option, I have to decrease, right? So my option will be this one. I hope you got it. Whenever you see similar type of question, you have to think in terms of the steps which we have taken to solve this question. See, whenever you are seeing a question, the picture is not important for you because picture always seems to be difficult. You have to divide that question into a part where you can solve it. So this is my approach in which I tell my student that you do not need to see the picture, the big picture which is given in the question. You have to see the pixel, the small part given in the question that you can solve very easily. Right? Shall we move now to the next question? A is correct, Charan. Instrument, which instrument you want to learn? Instrument usually basically comes in moving charges and magnetism, the galvanometer and the ammeter. And here if you want to learn about the potentiometer, I can go for that potentiometer. Do you want me to teach the potentiometer, ammeter, galvanometer, voltmeter? Yeah, it's very easy. Means if you want me to teach you an ammeter, what is ammeter? It's basically an instrument used to measure the current, right? It's an instrument used to measure the current. What is the ideal? What is the ideal resistance of an ammeter? The ideal resistance is 0. I want a practical resistance is that I want a very low resistance. Similarly, there is a galvanometer. A galvanometer is a sensitive device having a very small resistance Rg, and it requires a particular current to operate. Think in terms that galvanometer is basically an instrument which is used to detect the small current, feeble current, right? Or imagine that similar to the watch I am having, or similar to the any other appliances, electronic devices you are having, it wants a particular voltage and particular current to work properly, right? Everything in this universe, if we are designing, then we have a particular voltage, particular current that is required to work normally. So here also I'm telling you that I'm having a galvanometer which works perfectly when there is a current flowing through it is Ig and a resistance here is Rg. But now my desire is that I need to connect this galvanometer. I need to connect this galvanometer to a situation where I need to measure a very large amount of current. So if I'm going to measure a very large amount of current, I'm connecting this circuit at a location where very large current is flowing, but this galvanometer will only work with this value, because this galvanometer requires only this value, right? It do not matter that how much current is flowing in the circuit, it wants its Ig only. So the other current will pass through, and another circuit which is known as a shunt circuit. So I'll connect a shunt here. Shunt is a very small resistance connected in parallel. Shunt is a very small resistance connected in parallel. Okay, now you know that the voltage, at the top side and the lower side will be same. So you can write it that Ig Rg is equals to, so if Ig current is flowing through this side, I minus Ig current will flow through this side. So I'll be having a shunt I minus Ig current flowing through this side. So this is the equation which I am having, and sometimes you have to calculate the shunt. So if you want to calculate the shunt, you can easily get Ig Rg divided by I minus of Ig. Okay. Similarly, if you have to convert the galvanometer into the voltmeter is basically a device which used to measure the voltage, and we generally apply the voltmeter in a parallel. So we must be having a very high resistance for that. Let's solve that. What if I need to convert the galvanometer into voltmeter? So for converting the galvanometer into voltmeter, you need to connect a very high resistance in series with this. So if you connect a very high resistance in series with this, you got a voltage and that voltage will be equals to Ig Rg plus R. Okay, that is the value which you will get. I hope that this thing is clear. Prem Kumar, is it clear? Let's solve one question. If it is clear, let's solve one question on this. Yes, there is a question from JEE 2024 9th April shift 1. In this question, there is a galvanometer has a coil of resistance 200 ohm. Okay, so assume that there is a galvanometer. The resistance of galvanometer is given to you as 200 ohm, and it shows a full scale deflection. See, it shows a full scale deflection at this much. So what does it mean? It means that the current which is required to work properly for the galvanometer is 20 microampere. But now our desire do not ends here. The value of resistance to be added to use it as a ammeter of range 20 milliampere. So that means that I am going to increase the value of the circuit at which I am connecting. So what if I am connecting it through 20 milliampere? I need to connect it with the shunt, right? I need to connect it with the shunt, and the value of current flowing through it is I minus of Ig. You need to calculate the value of the shunt. The value of the resistance needs to be added to use it as a ammeter. So that is what you need to calculate. Very easy peasy lemon squeezy question. Solve it and do let me know that what is the answer. Prem Kumar, please solve it. I'm only giving you few seconds to solve this. 30 seconds, I think it's sufficient. One, one are you getting? Are you getting one? I'm Charan. For this, I require a scientific calculator. There is a calculation. But I can do it using the assumption method as well. This is microampere and this is milliampere. Okay, remember this. Micro means 10 to the power minus 6 and milliampere is 10 to the power of minus 3. So remember this thing. So this IGRG is equals to I minus IGS. This is what you need to find out. S is equals to IGRG, that means 20 into 10 to the power of minus 6 into 200 ohm divided by I minus IG. This means 20 into 10 to the power minus 3 minus 20 into 10 to the power of minus 6. So solve this question. 20 10 power minus 6 200 minus 3 minus it comes out to be 200 divided by 999 and it's coming to be 0.2. So your shunt is 0.2. This is your answer. This is your answer. Okay, my dear. Please provide PDF of your session, ma'am. Kirtika, as I'm looking, ma'am, I'm having a so nice beard and you are saying that please ma'am provide. I think that you need to go to the optician. I'll provide you the PDF. I have shared one link. In that link, you may be finding out if you have joined our Telegram group. If you are not on our Telegram group, you must be joining. You must join our Telegram group because on Telegram group, I have shared one sheet with you. On that sheet, for a physics subject particularly, I have designed a sheet in which I'm keeping the lectures which I'm taking, the serial numbers, the serial number like 1, 2, the topic which I am taking, right? And the PDF of this session I'm sharing with you. Handwritten notes because the PDF is like, this is particularly a one shot in which I'm covering the topic very fast and also I am covering the JEE Main 2024 questions, right? From your January and April attempt. So these sessions are very fast. So that's why I'm also providing you handwritten notes, which is there from my a full year course. So I'm also providing a handwritten notes, PDF of the session, handwritten notes you are getting, plus the highlighted NCRT you are getting. Okay, highlighted NCRT you are getting because this is very much required if you are going to give the board this time. So this is basically what you are getting, and also a practice sheet. There is also one link there for a practice sheet. So if you are not on our Telegram, please join our Telegram group. But for a physics subject particularly, I am having this sheet. Okay, and this is very, very important. In Telegram also, we are not getting PDFs of the session, sir. It's not like that I'm getting a world record. World record is like they have a very big beard, and if I'll keep that big beard, I will not be looking good, right? So I'm keeping that length only. Now I'm planning to have a big hair. Shall we move? Shall we move now? Shall we move? Yes. That's the question. See, again, we have to find out the equivalent resistance. I'm seeing a pattern in this. If you go for the previous year question of JEE 2024, you will be seeing that most of the time you are getting a question on equivalent resistance. Just you need to find out the equivalent resistance. The concept which you have studied in the class 10th, you have to use in your JEE exam. See, the beauty of the learning. So in this JEE 2024 9th April shift 1, you have to find out the equivalent resistance. I am giving you 1 minute for this question because you need to redraw the diagram. It looks a complicated diagram, right? But the answer is very simple. Just open it. Just open it and you will find question is very easy. Just open it and you will find that the question is very, very easy. Just open it. Redraw the diagram. That's why I'm giving you the time. Kirtika, you should come to my live classes, because when you come to the live classes, it seems to be like if you have any doubt, you can get it clear on the spot. And I'll remember that these are the students who are getting benefited from my lectures. You are not giving the answers. See, what I need to do is just open this. And if you open this, I'm keeping my A point here. So if this is A, 6 ohm I'm having here, 10 ohm, 5 ohm, 7 ohm, 8 ohm, 11 ohm, this 6 and this 8 is connected. After this 8, I'm having 10, 5, 7, 8. 11 ohm, 4 ohm, 8 ohm. This is P point. Okay, this point is drawn, this and this is connected. 10, 5, 7, 8. Okay, 10, 5, 7, 8 is there. Okay, this is clear. Now from 5 to the 8, we are having a value. Okay. Now this is the question which you have to solve. Fine. Now how you can solve this question, because this is what we are getting. Now this question is very, very simple. Why I'm saying that? Because I think that if you have studied well, you must have studied this type of question in which you have to join like that, right? Now these basically, if I redraw this, I can have 6 ohm, and these resistance, these three resistance are basically in parallel to each other. 15 ohm, 15 ohm, and 15 ohm. And here I'm having a 8 ohm. This is a particularly a ladder question which we have studied earlier as well. If they are same and they are repeating 3 times, so I can 15 divided by 3, it will be a 5 ohm. So my answer will be 6 ohm, 6 ohm, 5 ohm, and 8 ohm. So that will be 6, 5, 11, 11 plus 8, 19. So 19 ohm I am getting. Okay. 19 ohm I am getting. This is a very, very important pattern. I'm newcomer to your lectures. Okay, Charan, come to the next, come in the next class as well. My next class is on Monday. Okay, I'll be taking, I think that I'll be taking one session also on Sunday, but my scheduled session is on Monday. So Monday or Tuesday and Friday, I'm having the class as per my schedule. Okay, now all the other questions in this PDF is homework for you. Okay, I'll take a separate session on the topics which is left. So there will be a part 2 for the current electricity, but that will happen in a fast forward way in which I'll be solving the previous year questions only. I'll not be going to discuss the concepts. Okay, so I'm ending up my session here. Thank you everyone for joining the session. We will meet again in my next class. My classes timing is, my schedule, physics schedule particularly, physics my schedule is Tuesday at 6 p.m, Friday at 6 p.m. So Tuesday at 6 p.m, Friday at 6 p.m, you'll be meeting me. Okay, and if you face any issue, you can directly contact me. Bye bye. How much score you are getting, Charan? In case of any issue, you can contact me on my Telegram or in Instagram. My Instagram handle is, my Instagram/Telegram is at the @Manoj24. So you can message me, okay, if you face any issue in physics. So we'll meet again. Till then, bye bye.